Okay, everyone, we are on page 322. Your turn at the top of the page. Go ahead and pause the video and try to do these 3 problems by yourself, and then press play and check and see if you did them correctly. All right, number 4 says, write an inequality that represents the phrase, the sum of 1 and y is greater than or equal to 3. Check to see if y equals 1 is a solution. All right, so the first thing we have to do is write our inequality. Again, it gives us that direction right here. The sum of 1 and y is greater than or equal to 3. All we have to do is write exactly what that said. So we say the sum of 1 and y, we would write 1 plus y, and that's going to be greater than or equal to 3. I literally just wrote down what I read. The next part says, check to see if y equals 1 is a solution. So if we were to substitute 1 for y, would that be a solution? Is 1 plus 1 greater than or equal to 3? Well, no, it's not, right? That's equal to 2, so we know it's not a solution. So if we're going to type our answer in here, we would say 1 is not a solution because 1 plus 1 is not greater than or equal to 3. All right. All right, number 5, write and graph an inequality to represent each situation. So 5, the temperature in February was at most 6 degrees Fahrenheit. Well, remember at the beginning of this lesson, we said in a word problem, when you see the words at most, it tells you it's going to be less than or equal to. It's not going to be bigger than that. It's going to be less than that or equal to that at most. So if the temperature, I'm going to choose a variable. I'm going to say T for temperature. The temperature is going to be less than or equal to 6. It's not going to get bigger than that. So there is my inequality. Now I need to graph it. I know that it could be 6 degrees. So when I find 6, I'm going to make a circle and it's going to be colored in because it could be equal to that. But it's definitely not going to go above it. It's going to be less than that. So it could be anywhere down here in this section. And again, to check it, I pick a number that's in the highlighted area. Maybe I pick 2. And I plug 2 in for T. If 2 was T, 2 is less than or equal to 6. Is that true? Yes, it is, so I know I did it correctly. All right, number 6. Each package must weigh more than 2 ounces. Again, if I'm going to be writing an inequality, I have to pick a variable. I have to have an inequality symbol and then the number. So if I want to know about packages, maybe I'll pick P for package. The package must weigh more than 2 ounces. That means the package has to be bigger than 2. Has to be more than those 2 ounces. I'm going to graph it on here. Can the package be 2 ounces? Nope, it can't. So I cannot do a filled in circle. I do a open circle. It can't be 2, but it can be any of these numbers over here that are bigger than 2. And now to check my answer, I just pick one of the numbers that are in this highlighted area, maybe 7, and I plug it in for P. Is 7 greater than 2? Yes, it is, so I know I did it right. All right, good job. Let's go down to the bottom of the page. Guided practice. Again, pause the video, try to solve these on your own, and then watch it and see if you did it right. Number 1, graph 1 is less than or equal to x. Use the graph to determine which of these numbers are solutions of the inequality. And then it gives us numbers -1, 3, 0, and 1. So the first thing I have to do is I have to graph this inequality. If I know that x is greater than or equal to 1, I know it could be 1. So I come over to my graph and I say, I know it could be 1, so I'm going to color that in. And x is going to be anything bigger than that. And actually, I read that wrong. It should be 1 is less than or equal to x. But still, it's the same thing. 1 is equal to or less than x. So x has to be bigger over here. Now, it gives us some possible solutions, and we have to say if they would work or not. So we can use our graph to help us. If we look at -1, could -1 be a possible answer? Well, no. It doesn't land in this highlighted area. It's way over here, so no, it won't work. How about 3? Could 3 be a possible answer? Well, it's in the highlighted area, so yeah, 3 could work. 0, if 0 is over here, it's not in the highlighted area, so no, 0 is not a possible answer. 1, we know it said it could be equal to 1, so 1 is a possible answer. So if we're going to write our answers here, I would say x could be 3 or 1. Those are the only possible solutions for that. All right, number 2 says graph -3 is greater than z. Check the graph using substitution. So first let's graph it. We know that -3 is going to be bigger than z. It doesn't say it's equal to, so we know we're going to have an open circle at -3 because it can't be -3. It's kind of a crazy circle. And z, -3 is bigger than z. It's greater than z. So z has to be somewhere way down here on these sides. Any number down that way would work. It does say check the graph using substitution. So again, I just substitute a number that's in the highlighted area, maybe -5, and I say, if I put -5 in for z, would it be true? Is -3 greater than -5? Yes, it is. So I know I did it correctly. Number 3 says, write an inequality that represents the phrase, the sum of 4 and x is greater than 6. Draw a graph that represents the inequality and check your solution. Again, when I hear those words, the sum, I should know automatically I'm adding. So the sum of 4 and x, so add 4 and x, is greater than 6. It's going to be bigger than 6. If I'm going to graph that over here, I know it does not include 6, but I have to think, okay, what could x be to make this side bigger than 6? Well, I know I have to add it to 4, and if I added 2 and 4, I'd get 6. So I know 2 would kind of help me, but it doesn't include 2. So I come over to my graph, I'm making a circle at 2 because I can't do 2, but it could be anything bigger than 2. So it could be any of this over here. It says check my solution. I do that by picking a number in the highlighted area. Maybe I'll pick this 4, and I'll substitute in 4 plus, and I chose 4 as x, so I'll put another 4, is greater than 6. Is that true? Is 8 greater than 6? Yes, it is, so I know I got it right. Number 4, during hibernation, a garter snake's body temperature never goes below 3 degrees Celsius. Write and graph an inequality that represents this situation. So, if I'm talking about the snake's body temperature, I'm going to use a variable. Maybe I'll pick T for the temperature. If the temperature never goes below 3 degrees, I know I'm working with 3 degrees, and the temperature has to be bigger than or equal to 3. But it can't be less than 3. So there's my inequality. Now I'm going to go over and graph it. Because it could be 3, I want to do a circle that's filled in on 3 to show that it could be that as a possible solution, but it also could be anything greater than 3. Let's go ahead and check it by picking a number in the highlighted area. I'll pick 4. If I plug 4 in for t, is 4 greater than or equal to 3? Well, it is, so I know I did it right. All right, let's look at the bottom. It says, write an inequality to represent this situation. Nina wants to take at least $15 to the movies. How did you decide which inequality symbol to use? Well, at the beginning, again, when we looked at this words at least, that means she could take an amount or anything more than that amount, but not anything less than it. So we know we have to pick a variable, and we know she's trying to figure out how much money to take, so I'm going to pick M for money. The money that she wants to take at least $15, so she could take $15, so we know it could be equal to 15 or more. So the money could be greater than or equal to $15. And then to describe how we pick that, I'm going to type in here. I'm going to say M is greater than or equal to 15, where M represents the dollar amount Nina wants to take. The at least means she wants to take $15 or more than $15. She doesn't want to take any less. All right, that's a good answer. You are done with page 322.